Hello class, welcome to part 3 of week 2 videos. We're going to start in section 2.5 and we're going to cover 2.6 and 2.7 as well. So let's start with our first one. It says solve the inequality, give the solution set in both interval and graph form. Okay, so let's look at what we're dealing with here. We have an inequality where we have a compound inequality. There's two of them going on. So when we go ahead and solve for x, we're trying to get x by itself. We're going to still do the same rules. I have a plus 4, so I'm going to minus 4. But I have to minus 4 from this 16 and from this negative 6. So I have to minus it from all three parts. Okay, so a little different there. So we have negative 10 is less than or equal to 2x, which is less than or equal to 12. Now we go ahead and undo multiplication with division. So we divide by 2. And we have negative 5 is less than or equal to x, which is less than or equal to 6. So what we are going to do is we want to graph this and put it into interval notation. So the first thing I'm going to do is graph it. And then once you have the graph, you can sort of tell what you need to do for interval notation. Okay, so let's get some numbers on our number line. Notice that I'm working at negative 5 to 6, so I'm going to put 0 here. 1, 2, 3, 4, negative 5. And we have 1, 2, 3, 4, 5, 6. Okay. So what this says is, on this first statement here, this is negative 5 is less than or equal to x. If you read it the opposite way, it's x is greater than or equal to negative 5. Well, greater than or equal to negative 5 is from negative 5 to the right. What we want to do is we need to figure out how to notate at negative 5. So there's some notation you need to use. When you have a less than or equal to or greater than or equal to, you're going to use brackets. When you have a less than and a greater than symbol, you're going to use parentheses. So what you want is your bracket to go in the same direction as your line that you're drawing. So notice ours is working right. So at negative 5, I want a bracket opening to the right. My other portion I'm working with is x is less than or equal to 6. So I'm going to go to 6 and I want less than or equal to. And again, this is a bracket because we have a less than or equal to symbol. Now what we're looking for is we're looking for the area where they overlap. So we're looking for the AND statement. So we want both the red and the green. So notice this is only happening between these two. So our final answer when we graph is the tails on the end get removed, and we're just talking about the portion between these two numbers. Now, when we go to the interval notation is basically what you see here removing the number line. So I'm going to have the same brackets that I have on my number line, and I'm going to use the same numbers, and I want to throw a comma in between them. So this is our interval notation, and this is our graph. Let's look at a word problem dealing with our inequalities. So Faith earned scores of 90 and 82 on her first two tests in English literature. What score must she make on her third test to keep an average of 84 or greater? Okay, so we're finding an average. So we need to remember how to find an average of numbers. Well, to find the average of numbers, we add the results up and we divide by the number of items. So in our case, we're talking about a total of 3 tests. So we're going to add them up and divide by 3. So we have 3 test scores to add up. I know the first test score is 90, plus the second test score, which is 82, plus the third one. Well, what score must she make on her third test? That's the unknown. That's the variable. Here's where your inequality part comes in. We want to know when the average is 84 or greater. So it can be 84, which means you're allowed to be equal to 84, or greater, which means I want this result to be greater than or equal to 84. We're allowed to equal 84 or greater. So now we go ahead and solve. So we multiply by 3 on both sides to get rid of that denominator. And we have 90 plus 82 plus x is greater than or equal to 252. And you multiply those. And we add these up. That gives us 172 plus x is greater or equal to 252. Subtract 172. And that gives me x is greater than or equal to 80. So on the third test, we have to be greater than or equal to 80 to keep an average of at least an 84. So let's look at solving another inequality. This is going to be in section 2.6. So for the compound inequality, give the solution set in both interval and graph form. So we're basically doing the same thing we did 2 problems ago. We want to solve these and then represent it on the graph and in the interval. Okay, so the first one. So I'm going to add 4 to both sides. And that gives me 3x is less than or equal to 12. Divide by 3. And we have x is less than or equal to 4. So let's go ahead and graph this one and see what we get. So we're at 0, 1, 2, 3, 4. I want less than or equal to 4. So less than or equal to is left. And we're going to have a bracket at 4 because of the less than or equal to symbol. In my next one, subtract 1. And we have negative 4x is greater or equal to negative 16. Divide by negative 4. And we have x. Now remember, we divided by a negative, so we need to flip the inequality. Okay, so notice that I have x is less than or equal to negative 4. Well, that looks familiar. Just happens to be the same solution. You're not going to always get the same solution. So again, we're at 4. We're less than or equal to, so to the left. And again, we have a bracket at 4. Now, what we're looking for is we're looking for the AND statement. So we want to know where these 2 graphs overlap. Well, they overlap from 4 all the way left or less than to negative infinity. So when I write my interval notation, again, I'm going to keep the negative infinity. I'm going to come up to 4. We're going to have the bracket on 4. And now I just need to figure out, well, what do I need to have on the infinity? Well, infinity and negative infinity always have a parentheses because these are not actual numbers, so you can't include the infinity symbol. This is telling you that it's going to go on forever to the left. Okay, let's continue on with 2.6 and we'll look at number 41. It's going to be very similar, but notice that in between our values is the word or. And we'll talk a little bit more about that once we get it graphed. So let's go ahead and solve these. So subtract 2. And that gives me x is greater than 5. So when I go to graph this, I'm at 0, 1, 2, 3, 4, 5. Now we have a greater than symbol, so that means to the right. But this is telling me to use a parenthesis because it doesn't have the equal to. Okay, let's look at the other one. Well, we're going to subtract 1. So we have negative x is greater than 5. And then we have to divide by negative 1. Remember, there's a negative 1 in front. So this gives me x. I go ahead and flip the inequality, and we have a negative 5. Again, we're flipping because we're dividing by a negative. So let's go to negative 5 on our number line. 1, 2, 3, 4, negative 5. Now we're less than, which is to the left. And again, we're using a parentheses because of the less than symbol. Now the word or means we're trying to find where the solution is to one of them or the other. They don't have to overlap. With the and statement, we're looking for where they overlap. So any solution to these is part of the final answer. So notice that my red one goes left forever to negative infinity. So when I write that in interval notation, I have negative infinity. It comes all the way to negative 5. Notice I'm using a parenthesis. My blue solution starts at 5 and goes all the way to positive infinity. I have a parenthesis. The word or also tells me the notation is considered a union. So you have a little u in between them. And that represents the solution to our compound inequality. So we have a couple from section 2.7, and it deals with absolute values. So let's go ahead and look at 2.7. So in 2.7, it says solve the inequality and graph the solution set. Okay. So we're dealing with the absolute value of r plus 5 is greater than or equal to 20. The idea of absolute value is the distance we are from 0. So the absolute value of 5 and the absolute value of negative 5 are both equal to 5 because those numbers sit 5 units away from 0. So when we look at this one, it tells us how to generate those two solutions. We're going to take our one absolute value inequality and break it apart into two. So I'm going to break this apart. The first one, notice, is the same except the absolute value has been removed. So I'm going to have r plus 5 greater than or equal to 20. We have the word or, which remember that makes a difference in our final answer, so we want to make sure we use or. And then the second one is still the same r plus 5. But notice the inequality has been flipped, so this becomes less than or equal to, and the opposite of the number in the back, which is negative 20. We go ahead and solve this by subtracting 5. So we get r is greater than or equal to 15. Subtract 5. and r is less than or equal to negative 25. To graph these, we go ahead and look at r is greater than or equal to 15. So I'm going to go up by 5s on this one, just to get to 15. Well, greater than or equal to 15 is a bracket at 15 to the right. And then we'll go to negative 25. And we want less than or equal to negative 25, which is left. So this one doesn't ask us to put it into interval notation, but we definitely could. If we wanted to write this in interval notation, this one goes to negative infinity. So we have negative infinity to negative 25. We have a bracket on negative 25 with a union. Starts at 15 and goes to infinity. So it doesn't specifically ask for the notation, but we could present it. Okay, let's go ahead and look at the last one for week 2, which is from section 2.7 as well. This is number 83. And this deals with an absolute value equation. And this is actually when we have the absolute value equal to the absolute value. So let's look at how to break this one apart. So what we're going to do is, notice the first one we break apart is going to be exactly the same, but no absolute value. So we have 6x equals 9x plus 1. Or, in the second one when we break it apart, notice we have the same, the 6x equals, now we have the opposite of what we have in the second one. So notice how we threw a negative sign in front of what was in that parentheses, the second one, and we're going to go ahead and work our problems from there. So in the first one, I'm going to subtract the 9x over. That gives me negative 3x equals 1. And then divide by negative 3, and then we should have a solution. So we have x equals negative 1/3. Or we go ahead and solve the second one. We have to distribute a negative in. And then add the 9x. And that gives us 15x equals negative 1. And then divide by 15. And we get our other answer. X equals negative 1/15. So this is an OR statement again, so either of these can be considered solutions. So when I write my solution, I'm going to write it as negative 1/3, comma, negative 1/15. And that would be considered our solution for this problem. Since it's an OR statement, we're allowed to have both of them. Okay, well, I hope the videos were helpful this week, covering Chapter 2. If you have any other questions, feel free to let us know.